Hello everyone, welcome back to my channel. My name is Rakshit Subramanya and today I am going to be presenting on the topic distance vector routing with example in computer networks. So computer networks is a subject that comes under our engineering in information science, and today I am going to be presenting on this topic. So coming to the introduction first. So let us know what is distance vector. So distance vector is a type of routing protocol which is used in computer networks. So it mainly enables routers to share their data or the data packets from one system to another system through with the help of the network topology. So as you can read here, it enables routers to share information about the network topology with their neighboring routers. The primary goal is to determine the best path for the data packets through the network. So as you can see here in the diagram, you'll see what the definition meant about. So the routers, as you can see in the diagram, the routers pass through different routers such as A, B, C, D. They use different routes and they pass information from one router to another. So coming to the distance vector, how the distance vector routing works. So the router periodically shares a routing table. It is a table which has a set of cost values from every direction. So a router periodically shares the routing table with their directly connected neighbors, that is the neighbors next to them which are connected to them. So each router calculates the best path to the each destination based on its distance matrix. So the distance metric is typically measured in hops, which we also say hop count. How many hops does it take to reach the destination? So the distance matrix is typically measured in hops, which indicates the number of routers a packet must pass through. So some of the key characteristics of distance vector routing are that it has a very simple algorithm to implement. So it easily determines the path to your destination, and the distance vector protocols are generally less scalable compared to your link state protocols, and each router maintains a table of distance to and it sends it to its forwarding neighbor. So it collects it uses a little bit amount of, not little bit, quite a bit amount of your memory, because each router is going to use or create a new table every time. So it's going to consume memory. So here you can see in the diagram the different types of routing protocols that are present now and used these days. Okay, now coming to the routing table structure. So here you will see how the routing table structure is. So as you can see in the diagram, the first one is usually the destination, and the next one is how many hop counts, and the third one is the interface. So a routing table contains of destination address and associated distance matrix. So each entry also includes the next hop router to each destination. The routing tables are updated based on the information received from the neighboring routers. So here is an example. So here in the diagram you have a basic graph that you can see here how it is supposed to happen, and you have a table which says the starting node is C and how the hop table is made for it. So you can go through this diagram to understand. So considering three routers A, B, C connected in a triangle, so this is an explanation as a simple one. The router A knows the distance to B is 1 and the distance to C is 2. So the router B knows that the distance to C is 1. After sharing the tables, router A updates the distance to C as 2 via B, confirming that it is the shortest path. So this is a very simple example you can get about distance vector routing. So now one of the concepts in distance vector routing, or how one of the algorithms which is used over there, is also known as the Bellman-Ford algorithm. The Bellman-Ford algorithm is commonly used in distance vector routing protocols as it helps routers to calculate the shortest path between each destination based on the distance vectors. The algorithm iterates through each routing table and updates it until no changes can occur in that given table. So now seeing the protocols utilizing the distance vector routing. So there are two mainly or widely used protocols in distance vector routing, that being the routing information protocol, that is RIP, and the inter gateway routing protocol, that is IGRP. The RIP uses a max hop count of 15, making it suitable for small networks. But when you take into account of the bigger networks, the IGRP, which is developed by Cisco, supports larger networks and includes more complex matrices, which compared to like the RIP is very powerful and is not needed for small networks usually. Now coming to the advantages of distance vector routing. The simplicity and the implementation of the distance vector routing makes it very user friendly for networking administrators. So these distant vector protocols can quickly adapt to changes in the network topology. They are also very effective to smaller networks where routing updates are manageable. Once again, you have another diagram here which has the table, and it shows you how the traversal and the other aspects are going to take place. So now looking at the disadvantages of distance vector routing. So the distance vector protocol can lead to a routing loop and the count goes off into infinity. The general and the second, so that is the first thing, meaning it goes off into a loop, the same numbers keep repeating once again, it doesn't stop, it goes off into a non-ending loop. And the second drawback that you see over here is that it is compared to the link state routing, is generally very slow. And the third one, as we mentioned before also, it has its scalability of the distance vector routing, that is mainly the RIP and others, are very limited. So this leads to drag down in the performance of your networking system. Now coming to the practical applications. So distance vector routing is like very common used among the small and less complex networks. So it is often used where small amounts of networking is required, like a lot of computation is not there. So in such kind of environments, the distance vector routing, especially like RIP and all, are used. There are larger enterprises which may use the IGRP, or they even might not prefer distance vector routing and move into link state routing. So in conclusion, what all we learned today is that the distance vector routing is essential for concepts in the computer networking chapters. So, and despite the limitation, it remains very useful in specific applications, which is our distance vector routing, and understanding its principle helps network professionals design effectively routing strategies. So before we end, there is another diagram here with another example of how distance vector routing works. So you can go through it. Hope you understood something from my video. Thank you.